Here is our quotient rule. We're going to color code things again. So in color coding things, when you have one function divided by another function, what happens? You keep your bottom function the same, then multiply by the derivative of your top function, subtract, then keep your top function the same, multiplied by the derivative of the bottom function. So very similar to the product rule in that you're keeping one the same, multiplying by the derivative of the other one. In the quotient rule, we're subtracting. And then in the quotient rule as well, we keep the bottom one the same and square it on the bottom. So color coding it. Similarly, in Leibniz notation, we have one function divided by another function. Keep that bottom function the same, times by the derivative of the top function, subtract. Keep your top function the same, multiplied by the derivative of your bottom function, all over your bottom function squared. So this one, the order matters, whereas the product rule, it doesn't matter which one you start with, which one you keep the same first, multiply by the derivative of the second, because you're adding. Now that you're subtracting, you need to keep your bottom one the same first. I don't know if it helps to think that these two go together. Somehow you need to remember that you're going to keep the bottom one the same first. So in this one, it says find the derivative, and we want to simplify our final answer as much as possible. So for our derivative of this will equal, keep the bottom function the same, multiply by the derivative of the top function, then keep the top function the same, multiplied by the derivative of the bottom function, divided by the bottom function squared. Simplify our final answer. So what we're going to look at is what happens when we combine like terms on the top, multiply things out. So I would get 9x cubed minus 21x squared minus 3x cubed over 3x minus 7 squared. And we generally like to factor things in case there's something that'll simplify further. So looking on the top, well, on the top I have some like terms. I'll put those together first. 9x cubed minus 3x cubed will give me 6x cubed and we can factor out on the top a common factor of a 3x squared. That will leave me with 2x minus 7 over 3x minus 7 squared. Once it's factored, we check if there's any factors that can cancel out. In this case, there are none, so we would leave it like this. Here is one for you to try. There you go. So without simplifying it, there you go. If we wanted to color code things here, there's our bottom function. There it is, and there it is. There's our top function. So those are the ones that stay the same. And then you find the derivatives of the other one. So recall that when we find the derivative, what we're finding is an equation for the slopes of any tangent line at any point. Okay? So if we want to find the slope or the gradient of a tangent to this crazy function at x equals -1, we would need to find the derivative and then plug in -1 to find that slope. We can then find the equation of that tangent line at that point as well. So what does this look like? Well, we'll start by finding our derivative. And in this case, it'll be a quotient rule. We'll keep keep the bottom the same, derivative of the top, subtract, keep the top the same, derivative of the bottom over, over the bottom squared. So it ends up being quite a big equation. At x equals -1, what would we get? If I plug in -1 into each of these, I'm going to get 1 plus 1 times 3 minus a -1 times a -2 all over 2 squared. And simplifying this, did you get 6 minus 2, 4 on the top, 4 on the bottom, and we get a slope of 1. Okay? How do we find the equation of the tangent line then? Well, we need to know a point on the line. We need 2 important pieces of information to find an equation. We need the slope, which we already know is 1. And we need a point